Thank you.
I'll do the rest and turn it in tomorrow.
Oh my God.
Question on the homework. Questions on the homework.
You got cake for me? Let's
All right. If there's no questions on the homework, we're going to go on and start the lesson for today. We're starting on solving rational equations. So we're trying to find what value of x will make these two be equivalent, be equal. And the first part of solving rational expressions, rational equations, is finding the restrictions. The values of x that will make the denominator be 0. Because these restrictions, if they do come up as a solution, we can remove them because we know they will be extraneous solutions. So what's going to make the denominator be 0? One of them is going to be x plus 1, and the other is 4x plus 5, because whatever value of x that will make these be 0 cannot be a solution. Subtract 1, so it's telling us if x is -1, it would make the denominator be 0, so one of our restrictions is that x cannot be -1. On the other one, we would indeed minus 5 from both sides. Telling us 4x equals -5. Divide by 4, telling us x cannot be -5/4. So if we get either one of these as a solution, we can remove it because it's one of our restrictions. -5/4, yes.
Stop.
Guys. Now, next thing we need to find is the least common denominator. We use this in addition and subtraction so that we can be able to add or subtract the problems from each other. Here, we're going to use it a little bit differently. Now, the first thing we need to do before we can find it is to make sure all the denominators are factored. Well, x plus 1 and 4x plus 5 are as simplified as they get. So part of this least common denominator is going to be x plus 1. The other part is plus 5. So the least common denominator, if we're going to use this here to help us solve, is x plus 1 and 4x plus 5. Now, unlike with addition and subtraction, we're not going to multiply each of the fractions on top and bottom by this. We're just going to multiply the whole equation by it. So each expression, each rational expression, we're going to multiply by our x plus 1 and 4x plus 5. Now for the first one here, again, when we do this, we're multiplying it by the numerator only. So we'd have 3 times our x plus 1 times our 4x plus 5. It's still over our x plus 1. On the other side, we'll have 9 times our x plus 1 times 4x plus 5 over 4x plus 5. Questions on this here?
So we're just multiplying each one by both of the bottom.
Pretty much, yes. As long as, yeah, because we're finding the least common denominator, which in this case ends up being just x plus 1 and 4x plus 5. Yes. Question? Any other questions on this here? All right. Now, if we look at the one on the left, we do have something in common on top and the x plus 1 will cancel out. leaving us with 3 times 4x plus 5. On the right-hand side, we have 4x plus 5 in common. So the main reason we multiplied the entire equation by this least common denominator is that it got each of our rational expressions to simplify down. We don't have any more fractions left. Questions on this here? For hockey?
You think 49ers should have won?
You probably wasn't nicer.
Yeah.
They should have won. The Chiefs suck.
They honestly don't.
All right, guys. Here, we're going to multiply through by 3. 3 times 4x is 12x. 3 times 5 is 15. We'll do the same thing with 9. 9 times x is 9x, and 9 times 1 is plus 9. Now, since we do not have an x squared or x cubed, we just have an x term. We need to get x by itself to solve. We're using multi-step for solving multi-step equations. So the first thing we can do is minus 12x from both sides. And when we subtract 12x from both sides, negative 12x and 12x is 0, leaving us with 15. 9x minus 12x is negative 3x plus 9. What can we do next? We'd subtract 9, because again, since we don't have an x squared, we just have x term, we're just getting it by itself. So we want to get our constant terms on one side. So what that'll tell us is that negative 3x is equal to 6. And last but not least, to solve for x, we would divide by negative 3. Because we want to know what the value of positive x is, so we would divide by negative 3, telling us x is negative 2. I don't know. But that's it.
That's easy.
What is negative 2 one of our restrictions? No, so it works. Because if I wanted to check this, we could say 3 over negative 2 plus 1 and 9 over 4 times negative 2 plus 5. And we could simplify each one of these here and see if we get the same value. Now the one on the left, because we'd have 3 over, well, negative 2 plus 1 is negative 1. And 3 divided by negative 1 is negative 3. On the right, 4 times negative 2 is negative 5. Negative 5 plus 8 is negative 3. And 9 divided by negative 3 is negative 3. These are indeed the same. So x equals negative 2 is the correct answer. Questions on this here? So let's look at our restrictions first. We have our x plus 2 and 3x plus 2. We're going to find our restrictions first. Now, for the most part, this part of the chapter, the restrictions are not going to come into play. So we could subtract 2 from the first one and see that x cannot be negative 2. For the other one, we would,
What if it comes out?
then we just remove it.
Oh.
We remove it from our solution set. It doesn't work. It is what we consider or call an extraneous solution. It's a solution that works for the mathematics or kind of our process in solving, but does not work in the original problem. An example of that would be, we know that the area of a square is 16 units. Well, area of a square is length times width. Well, that'd be x times x is 16. To solve it, we take square root of both sides. Whenever we take the square root of both sides, we add the plus or minus, yes? So according to the mathematics, how we solve this, it told us that the side length of x is 4, or the side length is -4. But can we have a side length, a length of -4 units? No. So that's removed. It's an extraneous solution, so the only solution is 4. Same thing's true with these here, because according to the process we do to solve it, these could still show up, but we know in the original problem, -2 or -2/3 will not work because it gives us a denominator of 0. So we still have to think about those or keep those in mind.
So if it's over 0, then you can live with this.
We can't divide by 0, right? And it's not so much that it doesn't exist. This is kind of off on a sidetrack, but multiplication, 2 times 6. Well, this is just a fancy version of addition, because we're saying 2 groups of 6, or 6 groups of 2. So 2, 2, 2. 6 times gives us 12, or 12 times 2 times 6 is 12. Same thing with division. 12 divided by 2 is 6. It's just a fancy version of subtraction. Because 12 minus 2 is 10. 10 minus 2 is 8. 8 minus 2 is 6. 6 minus 2 is 4. 4 minus 2 is 2. 2 minus 2 is, well, how many did we have? 1, 2, 3, 4, 5. It's a fancy version of division. So if I said 12 divided by 0, 12 minus 0 is,
Yeah, you mixed up. I don't know. It's like. Yes, it's 12. I don't know.
I think you're wrong. I think you're wrong.
so doing the same thing. Well, 12 minus 0 is 12. 12 minus 0 is 12. Are we actually decreasing at all? No. So this is not possible. We can't divide by 0. All right. All right, guys. Let's focus back in. Least common denominator. Well, x plus 2, 3x plus 2 are simplified. There's no greatest common factor. No way we can reduce it. So for this here, the least common denominator would be, and we're going to multiply each of these terms by x plus 2 and now, as we saw in the last one, and it'll work out this way here, well, the x plus 2 on the left, and what we're multiplying it by will cancel, leaving us with 2 times. We'll still have the 10, but our 3x plus 2 cancels with that 3x plus 2, leaving us with 10 times x plus 2. Now, now that we have this here, we can go on and distribute. 2 times 3x is 6x. 2 times 2 is plus 4. We can do the same thing with our 10. 10 times x is 10x. 2 times 10 is 20. Now we need to get x by itself. So what can we do first? We can subtract 6x first. Because we need to get x by itself. And we did. Now we just need to get the constant term on the other side. And what this tells us is that 4x is equal to, and last but not least, divide by 4, telling us x is -4.
Yeah.
Is that one of our restrictions? No. So that is our solution.
I can do math.
Questions on this here?
If she can be our next.
Yeah, like y'all know the answer to every single problem. We solved just one of it.
Actually, you'll type it out.
All right. Let's look at this next one here. Now, the two places where the denominator can be 0, we can actually plug in a value and get 0, is 5x and x minus 7. We divide by 5, telling us x cannot be 0. 0 divided by 5 would be 0. Here we can add 7. So x equals 7, which means x cannot be 7. Now, let's look at this here. What do we need to multiply through this one by?
5x minus 7.
So 5x and 5x and x minus 7. Because here our x minus 7 and x minus 7 would cancel. On the other side are 5x and 5x. And what that leaves us with, 3 times x minus 7, 2 times 5x. Now, just like the last one, we can distribute. 3 times x is, 3 times negative 7 is negative 21. And 2 times 5x is now, since the constant terms are already on one side, we're going to subtract 3x. Because our 3x and 3x will cancel. 10 minus 3x is 7x equals negative 21.
Negative 3.
We divide both sides by 7.
Negative 3.
Minus x is equal to negative 3.
You don't like Christmas? Actually, every year. I like it.
Questions on any of this here? Restrictions. So our x plus 3, we would minus 3 from both sides, telling us x cannot be negative 3. X equals 3, so x cannot be 3. So x cannot be positive or negative 3.
Can we just put x cannot be plus or minus 3?
We could. Yeah. And yes, we would multiply everything by n x plus 3. And we only need each one of them once because they only show up in each denominator once. On the right, left-hand side, x plus 3 and x plus 3. And x minus 3 and x minus 3. Leaving us with negative 4 times x minus 3 is equal to 5 times. Now at this point here, we would distribute the negative 4. And then 5 times x is 5x. 5 times 3 is 15. So we have negative 4x plus 12 equals. So we can add 4x to both sides, telling us 12 is equal to 9x plus 15. 4x and 5x.
5 plus 4,
Oh, okay.
and then you minus 12.
15. Because we want to get the x by itself. 9x is equal to negative 3. Yes. Now, 3 over 9 does not reduce to an integer, but it does reduce to negative 1/3 because 3 and 9 have a common factor of 3, and it would reduce to negative 1/3. Now, 1/3 is not one of our restrictions, so it is our solution.
This class only going by slow because I'm hot.
I was breaking.
Questions on this here?
Do we have to do another one? Or can we go to 8?
Let's do this one here. We'll skip over the restrictions because the restrictions are going to tell you what they are, is that x cannot be negative 5/2 or negative 8 over 11. So those are the two restrictions, because if we set those equal to 0 and solved, we would get these as our restrictions. Now what are we going to multiply everything by? 11x plus 8. Now our 2x plus 5 and 2x plus 5 would cancel. 11x plus 8 and 11x plus 8 would cancel. Now on the left-hand side, we have 1 times 11x plus 8, which is just going to be 11x plus 8. The other side, we have x times our 2x plus 5. Luckily, the left-hand side is just 11x plus 8 at this point. Here we have to distribute the x. 2x times x is 2x squared plus 5x. Now this is the first one we've had where we have a variable with an exponent greater than 1, 2x squared. Since this is a quadratic, we need to get it equal to 0. So the first thing we can do in getting it equal to 0 is to subtract 11x. Yes. Now our 5x minus 11x is negative 6x. Because again, we want to get this equal to 0. Now if the 2x squared hadn't been there, yes, we would divide by 6, because if we just have that x to the first, that x term, we get it by itself. For quadratics, anything with a degree above 2, our x squared, x cubed, we have that, we get it equal to 0. We want to get it equal to 0 to solve. Yes. Now, if there is a common factor that is a number, not a variable, here we have a common factor of 2, divide it out. We can divide everything by 2. Which gets us x squared minus 3x minus 4. Now this doesn't change our solutions. Now here, I do have it typed into the graphing calculator already. And if we graph it, the one in red is our x squared minus 3x minus 4. The one in blue is our 2x squared minus 6x minus 8. Now we see that on a whole, there are a lot of different points, but the two places where it crosses the x-axis are the same. Our solutions are still going to be the same. That's why this works. If you divide by a variable at this step where we divided by 2, you're removing a solution because we're removing an x from the equation. Because here we're just removing a constant term, a scalar. Well, if we factor it, since the 4 is negative, our signs are opposite. Only factors of x squared are x and x, and our factors of 4 we want are 1 and 4. 1 and 4, 2 and 2. And this is the setup that we need, because if we check this here, x times negative 4 would be negative 4x. 1 times x is plus x, giving us a middle term of negative 3x, which is what we wanted. Zero product property states that any time we have two or more things multiplied together to equal 0, one of them must be 0. For x plus 1, we would subtract 1, telling us x is negative 1. For our other one, we would add 4, telling us x is equal to 4. Is either one of these one of our restrictions? No, so those are our two solutions. Also, when we graphed it, what values of x make the y value 0? Negative 1 and 4. We could have graphed it, yes. Because if we graph it and our solutions are integers, the graph will tell us. If we have negative 1 point, huh?
Those are the east ones on the test.
Yes. When we were just graphing.
Something on my shirt. Throw it at Abby, but it fell.
Luckily for this next one, the restrictions are pretty easy to find. So we have 3 spots. We have 5 over x, 7 over 4, and negative 9 over x. Now we have 3 denominators, x, 4, and x. Well, 4, there's no way to change its value. There is no variable there. Yes. Yes. But the other 2 spots, it's just x. And what value of x will make this be 0? 0. So x cannot be 0. Now the question is, what do we need to multiply everything by?
0. X.
So x and 4. So we're going to multiply everything by 4x. Now, even though x shows up twice in this equation, it's only showing up once in each of the denominators. So we only have to multiply each of these terms by x once. So we'd have the first one, 5 times 4x over x, plus 7 times 4x over 4. I'm just multiplying. Because the first spot here, the x and x would cancel, leaving us with 20. 5 times 4 is 20. Plus, in the middle spot here, our 4 over 4 would cancel, leaving us with 7 times x, so 7x. The 4 canceled, yes. And in the last spot, the x and x would simplify out, leaving us with negative 36 or negative 9 times 4. Questions on this here? Now, the only time we would need x times x or an x squared term is if that we had an x squared term in one of these 3 spots. So even though x showed up twice, it only shows up once in each denominator. So when just multiplying it by the single x, removed it from each of those there. Now this time, do we have an x squared term? No. Get x by itself. Minus 20 from both sides. These cancel, telling us 7x equals negative 56. Then we would by 7. Yes. Negative 8. And that's it. Questions on this here? We ready for the next one?
No, I don't think the book. Or, yeah, no, we won't. I doubt it. No, I'm not probably.
Let's look at this one here. Restrictions.
X cannot be 5, and x cannot be 0.
Yes.
Cannot be 1.
Not quite.
No? There's not a 1 over 1?
So even though it is 1 over 1, we can't put in a value there because we're looking for the ones where we can actually plug in a value for x.
Or we can leave that alone.
So we're going to leave it alone.
Got it.
Yes, because we're only looking at the spots where we can plug in a value for x. Because if we tried 1, so I wouldn't write this part because I'm just plugging 1 in. Because we have 1 minus 5 is equal to 3 over 1.
Do we have to write that?
No. Because here we can see in none of the spots we get a denominator of 0. And if we went on and finished this out, because that'd be, actually, and that works. But, okay. Question on how we got the restrictions. What do we need to multiply everything by? X. Because our x minus 5 is one expression. We can't just have the x. So our middle term. Now in the middle term, our x minus 5 and x minus 5 will cancel. And our other spot, the x and x will cancel. Now for the first one, we have 1 times x, which is just x times x minus 5, minus 8 times x, which indeed is 8x, is equal to 30 times x minus 5. Yes, and we distribute the 3. 3 times x would be 3x. And 30 times negative 5 would be negative 15. Now for our first expression, x times x is x squared. X times negative 5 is negative 5x minus 8x. 3x minus 15. Now this is one of the first times today we've had like terms. Negative 5x minus 8x is negative 13x. Now since we have a quadratic term, an x squared, we need to get this equal to 0. What can we do first? I would minus the 3x. Because minusing or adding the 13x is not wrong.
Oh, we're trying to get it all on one side.
We're getting it on one side. And here, either way would work. Adding 13x and then subtracting x squared would work. But I try to keep the variable with the biggest exponent, in this case x squared, positive if at all possible, and have the least number of steps.
So why is that?
It just makes it easier to factor or work with. Now, even if we end up having it's easier to subtract the variable with the bigger exponent, we can multiply or divide the whole thing by negative 1, which is just changing the signs, which is fine. And the last thing we would do is,
Dang.
I already did that. I'm working it on my paper and that's wrong.
It was heavy.
we add 15 to both sides, because we want to get this equal to 0. Now, what we can do with any of these here, because we have the graphing calculators, we know how to graph them. I can grab the graphing calculator, say y equals, we have x squared minus 15x plus, I have those flipped because it should be minus 16x plus 15. Well, we have one of them as 1. So 1 is one of our solutions, and 15. So x is equal to 1, and x is equal to, was either one of these a restriction? Nope. So those are our two solutions. Now, purple. Out there. So, Isaiah, you were saying we could add 13x squared, and that's fine. or add 13x, which would have given us x squared is equal to, that's adding 16x minus 15. We could then subtract x squared, telling us 0 is equal to negative x squared plus 16x minus 15.
We have to distribute that negative, so we have to do an extra step. I see.
Now, at that point, we could divide by negative 1. But we had negative x squared plus 16x minus 15. And if I graph this, we can see that it does flip, that they're going in different directions. But at 15, the y values are still 0. At 1, the y values are still 0. It changes all the other points except for our two solutions. So it's still
That makes sense.
not there. Now, we're going to finish this up. Tomorrow we'll do a few more of these. Tomorrow?
Can I get the homework?